Hi everyone, welcome to my channel. In this video, I will be explaining about Pyspark and its features, advantages, modules, packages, and finally, I will try to provide a simple operation on aggregating data frames in Pyspark. So let's start. Spark is, as you can see in the screen, it is Spark and Python. Uh, all Spark examples provided in this PySpark tutorial are basic, simple, and easy to practice for beginners who are enthusiastic to learn PySpark and advance their career in big data and machine learning. What is PySpark? PySpark is a Spark library written in Python to run Python applications using Apache Spark capabilities. Using PySpark, we can run applications parallelly on the distributed cluster, that is, multiple nodes. In other words, PySpark is a Python API for Apache Spark. Apache Spark is an analytical processing engine for large scale, powerful distributed data processing and machine learning applications. Most importantly, Spark basically written in Scala and later on, due to its industry adaptation, its API PySpark released for Python using Py4j. Py4j is a Java library that is integrated within PySpark and allows Python to dynamically interface with JVM objects. So to run PySpark, you also need Java to be installed along with Python and Apache Spark. We also require Anaconda Navigator. Uh, it will provide us the tools like Spider, IDE, Jupyter Notebook to run PySpark applications. I suggest to install Anaconda Navigator to run PySpark scripts in Jupyter Notebook and Spider IDE. Any tools you can use either. You can also use other IDEs like PyCharm, Visual Studio Codes. In real time, PySpark is used a lot in the machine learning and data scientist community. Uh, Due to the vast Python machine learning libraries, Spark runs operations on billions and trillions of data on distributed clusters, 100 times faster than a traditional Python applications. So most importantly, PySpark provides us 100 times faster processing than traditional Python applications. So who uses PySpark? PySpark is a very well used in data science and machine learning community as there are many widely used data science libraries written in Python. For example, NumPy, TensorFlow, um, yes, other are pandas. Also used due to its efficient processing of large data sets. PySpark has been used by many organizations like Walmart, Trivago, Sanofi, Fantastic, and many more. So, features of PySpark. Following are the main features of PySpark, that is, in memory computation, distributed processing using parallelized functions can be used with many cluster managers. For example, Spark, Yarn, Mesos. Also, we can consider standalone because to run PySpark in local computer, we begin with standalone. But this is not a cluster managers, but we can consider because it is also a standalone where environment where we can run PySpark scripts. PySpark is fault tolerant, immutable, lazy evaluation, cache and persistence. These are the features. Inbuilt optimization when using data frames. Supports NC SQL. What are the advantages of Pyspark? Pyspark is a general purpose in memory distributed processing engine that allows you to process data efficiently in a distributed fashion. Applications running on Pyspark are 100 times faster than traditional systems. You will get great benefits using Pyspark for data ingestion pipelines. Using Pyspark, we can process data on Hadoop, HDFS, AWS S3, and many file systems. PySpark also is used to process real-time data using streaming and Kafka. Using PySpark streaming, you can also stream files from the file system and also stream from the socket. PySpark natively has machine learning and graph libraries. Now, finally, the PySpark architecture. Apache Spark works on master slave architecture where the master is the driver and slaves are the workers. When you run a Spark application, Spark driver creates a context that is an entry point to your application, and all operations, transformations, actions are executed on worker nodes, and the resources are managed by cluster manager. Cluster manager types. Spark supports below cluster managers. As I have discussed previously, that standalone can also be considered as a cluster manager. A simple cluster manager included with Spark that is makes it easy to set up a cluster. It is cluster is defined as a multiple nodes. Apache Mesos. Mesos is a cluster manager that can also run Hadoop MapReduce and Spark PySpark applications. Hadoop Yarn, the resource manager in Hadoop 2. This is mostly used cluster manager. Kubernetes, an open source system for automating deployment, scaling, and management of containerized applications. Local, which is not really a cluster manager, but still wanted to mention as we use local for master in order to run Spark on your laptop or computer. Okay, so I think standalone is a simple cluster manager, and local, which I was discussing above, which we can run in our laptop computer. Now, PySpark modules and packages. Spark, PySpark RDD, PySpark DataFrame and SQL, PySpark streaming, PySpark MLD, PySpark graph frames, PySpark resource. It's new in PySpark 3. So these are the modules and packages. If you want to explore more on modules and packages, um, I will try to provide a video on the same in the next video or lecture. So Apache Spark ecosystem is Spark SQL, Spark Streaming, Spark MLlib, GraphX, Apache Spark Core API. So as we are using PySpark, let's for example, so Python API that we are using. Since Spark is built on Scala, we can also use Java, SQL, R for a few of the core APIs. PySpark RDD. So this is one of the um important uh, terminologies, or we can say abstraction of Spark, is a fundamental data structure RDD. So PySpark RDD is resilient distributed dataset is a fundamental data structure of PySpark that is fault tolerant, immutable, distributed collections of objects. Which means you create an RDD, you cannot change it. Each dataset in RDD is divided into logical partitions, which can be computed on different nodes of the cluster. RDD creation. So in order to create an RDD, you need to create a Spark session, which is an entry point to the Pyspark application. Spark session can be created using builder or new session methods of Spark session. Spark session internally creates a Spark context variable of Spark context. You can create multiple Spark session objects, but only one Spark context per JVM. Okay, so this is bit tricky to understand that Spark session can be created using builder or new session. Most more Generally we use builder, but we can use either of this. So Spark session internally creates a Spark context. You can create multiple Spark session objects, but only one Spark context per JVM. That means that if we are creating multiple Spark session objects, we can create only one Spark context per JVM. In case if you want to create another Spark context, you should stop existing Spark context using stop function before creating a new one. This is an example of how we can initiate a Pyspark application by creating a Spark session. These are the mm, statements we have to follow. For example, we need to import Spark session first. We need to import Spark session by writing these two statements. Then we need to create a Spark session using Spark session dot builder dot master dot local. As we are not running, let's say we if we are running on local, we need to provide master as local. Then we need to provide an app name. For example, this can be any app name XYZ. Then we need to provide get or create. We'll create a Spark session using parallelize function. Using parallelize function, we'll basically create as RDD. Spark context has several functions to use with RDDs. For example, its parallelize method is used to create an RDD from a list. So if we have a list, we need to convert it to RDD. Parallelize will help, as is given in the example. RDD equal to spark context dot parallelize function. So Spark context is what we have provided probably here or not. Um, so Spark context is when we initiate a Spark session, we also created a Spark context. So we can leverage the Spark context after creation of Spark session using text file. If we have a text file, so we can create a RDD from that as well. RDD to spark context dot text file from a text file. So Spark context is what it's an abstraction where using which we can create a RDD, also parallelize function and text files. Once you have an RDD, you cannot perform transformation and action operations. Any operation you perform in RDD runs in parallel. Okay. Now RDD operations. On Pyspark RDD, you can perform two kinds of operations. One is RDD transformations, another is RDD actions. Transformations are lazy operations. When you run a transformation, for example, update is a part of transformation. Instead of instead of updating a current RDD, these operations return a new RDD. So we need to here RDD is immutable, and whenever we apply any transformations into an existing RDD, we have the existing RDD will not be modified. Instead of that, a new RDD is created where the applied transformations are where the transformations have been applied and modified. So existing RDD will remain as it is. A new RDD will be created, which will be the modified RDD, and then we provide the RDD actions, operations that trigger computation and return RDD values to the driver. So why uh, it is lazy operations? Because lazy operations means that transformations have been applied, but it will not return a new RDD until and unless an action has been called. So we need to provide an action, for example, show or collect are few of the examples of actions. Um, RDD transformations. Transformations on Spark RDD returns another RDD, and transformations are lazy, meaning they don't execute until you call an action on RDD. Some transformations on RDDs are flat map, reduce by key, filter, sort by key, and return new RDD instead of updating the current. RDD action. RDD action operations return the values from an RDD to a driver node. In other words, any RDD operation or function that returns non-RDD is considered as an action. Some actions on RDD are count, collect, first, max, reduce, and more. Pyspark data frame. So when we are writing Pyspark applications, we came across data frames many times as a if we you are pursuing data engineering, data scientist role, data analyst role, or business analyst, we came across this. So data frame is a distributed collection of data organized into named columns. Okay, so let's say we are so why data frame is important here, because it converts any CSV file or any kind of file format to named columns, which is organized. It is conceptually equivalent to a table in a relational database or a data frame in R or Python, but with richer optimizations under the hood. Yeah, so basically, yes, it is conceptually equivalent to a table in a relational database, which is, as we can see the tables in a relational database, it is equivalent to that. Data frames can be constructed from a wide array of sources such as structured data files, tables in Hive, external databases, or existing RDDs. PySpark data frame is mostly similar to Pandas data frame, with the exception PySpark data frames and distributed in a cluster, meaning that the data in data frames are stored in different machines in a cluster, and any operations in PySpark executes in parallel on all machines, whereas Panda data frames stores and operates on a single machine. So the benefit or advantage of PySpark data frame as compared to a Pandas data frame is that PySpark data frames are distributed in the cluster, and any operations on PySpark executes in parallel on all the machine, whereas Pandas data frame stores and operates on a single machine. Also, the execution of data frame or data processing in data frames on PySpark data frame will be faster than a Pandas data frame, as it is running on multiple machines. In PySpark, is PySpark faster than Pandas? So due to parallel execution on all cores on multiple machines, PySpark runs operations faster than Pandas. So yes. Uh, so this will be an example of data frame creation from a list of data data frame. So yes, we have a list of data here. We have provided the schema as columns, that is first name, middle name, last name, date of birth, gender, and salary. Then we have created a data frame using create data frame method, provided the data and schema to the columns. Okay, so data frame creation. Here we can view the prints using the print schema method. We can view the number of columns and their data types. And using show method, we can view 20 elements of the data frame. Data frame operations like RDD data frames are also operations. So RDD and data frame has operations like actions and transformations. Data frame from external data sources. Data frames are created from external sources like files from the local system, HDFS, S3 Azure, HBase, MySQL table, etc. So below is in one of the example to create a data frame from a CSV file. So here spark.read.csv will create a data frame out of a CSV file, and print schema will uh, result into the number of columns along with their data types. So the supported file formats in Pyspark are CSV, text, Avro, Parquet, TSV, XML, and many more. Um, yeah, most of the times we can come across these file formats. Other than that, other file formats are there. mm, for example, Hive, Table, and others external databases. If we are reading from any cloud platform databases, for example, Aurora, or we are reading from a uh, data lake, S3, Google Cloud Storage. So this can also become as one of the file formats because data lake has objects, right? So we can read from them as well using PySpark. So that is all for in this tutorial. Thank you for watching and happy learning.